Okay, so this is the continuation of 10.8 notes. And just so we know, we're not doing example 4, don't worry about that. You can cross it out. The last example is intersections with circles. So if I have a circle, and I'm looking at that graph of the circle, okay? Sometimes I'm given an equation, and it won't clear out. Sometimes I'm given an equation where I have a circle and then I also have a line in a coordinate plane. And that line will come through there and it'll cross over in the circle. And you can see actually, so there's my line, okay? And it intersects, in this case, at 2 points. Those intersections are where the circle and the line have points in common. So that's what we want to find. We want to find the points of intersection, the points in common between these two equations. Algebraically, we're going to use substitution to do that. So this is a system of equations. And a system means that the two equations, or there could actually be more, are going to work together to help us get our answer. We're not going to substitute the larger equation into the smaller one. We're going to take the smaller one and substitute into the larger. It tells us that y equals x. So anywhere I see a y, I can replace an x, or vice versa, I can replace the x with a y. I'm going to replace the y with an x, and I get x squared plus another x squared equals 4. So this is my substitution right here, the y with the x. Now I have an equation with just x in it. I can combine like terms. That's 2x squared is equal to 4. Divide by 2, so x squared is equal to 2. And then you have to take the square root. When you take the square root, though, we actually get two values. We get one positive and one negative, plus or minus the square root of 2. Don't take it and put it in the calculator, do anything like that. Just leave it a square root of 2. So that plus or minus, that actually gives us two x values because we have 2 points of intersection. So one point is going to have a positive square root of 2, and one point is going to have a negative square root of 2. When x is square root of 2, then according to our equation of y equals x, y is also going to be the square root of 2. When x is negative square root of 2, according to our equation, y is also going to be negative square root of 2. So our ordered pairs would look like this: square root of 2, square root of 2, and negative square root of 2, negative square root of 2. So here is my answer. Those are the points of intersection. I'm also going to do number 5 here real quick. The process is exactly the same. I'm going to use substitution as well. It tells me that y is equal to negative x. So where I see the y in the first equation, I'm going to replace it with a negative x. And I'm going to put parentheses around that. Anytime I substitute, I always put parentheses around the thing I'm substituting. And that makes, when there are operations, that tells me, hey, I have to do this to the negative as well. So when I go to simplify this now, and again, there was what I replaced. I still have x squared here, and negative x squared, that's negative x times negative x. Well, that is also x squared. These two negatives make a positive. Combine your like terms. That's 2x squared equals 8. Divide by 2. X squared equals 4. And when you take the square root, this time x is going to be plus or minus 2. So I know that those are going to be in my ordered pair. One's going to be a 2, and one's going to be a negative 2. So let's look at the case of when x is equal to 2. When x is 2, it says y is negative of x, or the opposite of x. So that's going to be negative of 2, which is just negative 2. So that gives me an ordered pair of 2, negative 2. When x is equal to negative 2, y is the opposite of negative 2, which is positive 2. So that's going to give me a coordinate of an ordered pair of negative 2, 2. Okay, as promised, I actually did change the problem set a little bit because I actually changed the lesson just slightly. We're going to still do page 760, but the numbers are going to be numbers 1 through 8 and 11 and 12, and we're going to do all of those. Okay, have a nice evening, and I will see you tomorrow.